Hello everyone, we are going to demonstrate to you the Newton's ring experiment. This is the schematic diagram of the experimental setup.
Let us now analyze the setup for this experiment. This is a microscope used to focus on this circular Newton's ring obtained due to the interference, hence measure its diameter. This is the sodium vapor lamp of wavelength 589 nanometer, which is the light source of the experiment. The microscope consists of a scale which is used to note the position of the eyepiece, which is used to obtain the diameter of the ring. It has a main scale with list count 1 mm and a circular scale with list count 0.01 mm.
The theory of the experiment. Interference effects are observed in a region of space where two or more coherent waves are superimposed. Depending on the phase difference, the effect of superposition produces variation in intensities which can be seen through the microscope. These are the Newton's rings obtained under the microscope.
This is the Newton's ring assembly with a plano-convex lens. The system is illuminated by a light reflected from another glass plate which is illuminated from sodium vapor lamp. Loci of the constant air gap of thickness d will be concentric circles around the point of contact. If n is the refractive index of the medium and lambda is the wavelength of the light used, then for normal incidence 2d is equal to m lambda. If rho is the radius of the ring, then for small d, d is approximately equal to rho square by 2r. So this gives the radius of the mth dark ring, which is equal to rho square by m lambda. Also for bright fringe, rho m square is equal to 2m plus 1 into lambda r.
We will take the observations of the experiment. There is a main scale and there is a circular scale. The circular scale reading into least count plus the main scale reading will give us the total reading. In the observation table, after noting down the readings using the main scale and the vernier scale, we will plot the graph between m and rho m, which will be a straight line, and we will get the slope of the line and will do the further calculations to find the radius of the curvature of rings.
I am going to tell you about the precautions of this experiment. The first precaution is to avoid backlash error. Now, what is a backlash error? As you can see, when we use to rotate our vernier scale in clockwise direction, our main scale will move in the left direction and reading changes. But at the same time, if you want to go in the right direction and rotate our vernier scale in anti-clockwise direction for that, the reading is not going to change. The main scale is still there. It is due to backlash error. To avoid Now, the second precaution is when you are going to look through the microscope, you find that the gap between two Newton rings is very small. To observe this gap, you have to be careful that your microscope is focused perfectly.